1, 2, 3, 4. How did that happen? Well, when you pluck a string, it creates a vibration. That vibration moves columns of air in the surrounding area. That column of air then goes on to move another column of air, each one compressing the last one, which is a sound wave. That sound wave then reaches your ear and makes your eardrum vibrate on a minuscule level. And then you hear stuff. It's pretty cool.
Alright, so this is a guitar. It's an electric guitar. And how it works is, you have this little pickup here, right? Which is basically just a magnet with a wire wrapped around it. A coil. So, when a piece of metal, in this case it's the guitar strings, right? When it vibrates, it changes the magnetic flux of the magnet. It's just fancy for saying it's changing the field of the magnet.
Ooh.
And that flux creates a voltage, right? A voltage. And the induced voltage is gonna start oscillating, which is a fancy word for vibrating. It's gonna oscillate the exact same way as the string above it. And that goes into this little wire here that's go woo, and it goes in here, and you hear it. You hear it.
Science!
Science!
Rules. Alright, so how does a tabla work?
Tell us, Sagar!
Alright, so I got two drums here. One of them's got the bass, which is the lower sound, and the other one's kind of the treble, which gives a higher sound. And basically how this and a lot of other drums work is that when you strike it, it's obviously going to produce a sound with a certain frequency. And the tighter the skin, in this case the animal skin, because these are made of animal skin.
Cool.
And and the tighter the animal skin, which I would use by hitting around the rim of this, would increase the tension in the skin. And you can see the pegs here on this drum. As these pegs are pushed lower and lower, the tension in these strings are going to be increased. And as that tension is increased, the tune or the pitch of the drum will rise. So you hit this long enough, I'm not sure you can hear that, but it's supposed to go up. And the good thing about that is that's how you tune the drum, and that's how all drums are tuned. And let's see, the more flexible and the higher the frequency, Newton's third law actually works into this, because as you tighten the drum, there's a greater force when you tighten the drum, and the drum gives an equal but opposite force in the same direction. So as you strike this, the more force you use in your fingers to strike it, the louder the drum's going to be. So it's pretty much proportional to how loud you play and how tight the drum is in terms of how high the pitch is going to be. So that's a small overview of how the tabla is tuned and how it sounds.
Cool.
Cool beans! Bongos!
Now that we've shown you quite a bit of the physics of the instruments that we're all just so good at, we are now going to talk to you about how some of the history of physics and the history of our instruments have progressed over time and have led to the more modern and futuristic development of sound. And basically the knowledge of sound in general, the nature of sound, has led to a more intimate understanding of acoustics in general, which is why we see like the advancement of, you know, sound engineering and sound technology. And it's led to a more efficient methodology in designing instruments in general. So we see like different instruments going and transitioning from the previous years to the future. So we're going to explain a little bit more of that into detail coming up. Go.
For instance, the bell of the trombone here serves to project sound over a greater distance, and without knowledge of like the nature of waves and how to propel them better, we wouldn't have been able to create a functional bell. Same with the slide. It serves to like increase the volume of air that's vibrating within the trombone, which because a larger volume of air will vibrate at a lower frequency, it changes the note of the trombone. And had we not known any of this, we wouldn't have been able to create the instrument.
Sure. Alright, so initially guitars were all acoustic like this one, but it was kind of inconvenient in like large group situations that you have, you know, like big concert halls and stuff. So you can't, because you couldn't really hear it, and it was really like drowned out by the rest of the band. So when they invented the pickup on the guitar, which we've explained, really it helped just amplify the sound completely, and just being able to manipulate the mechanical vibrations into an electrical signal into the amp, it just really helped out, like understanding the magnetism and everything. It just developed music a lot.
Alright, so as we've seen, all of our instruments have been using quite a few principles of physics, and those physical principles have evolved over time from the history of the instrument. And the important thing is that as we continue to study these branches of physics to which the music applies, we can truly influence the way music is played permanently. And we can kind of take music to the next level by understanding more and more properties of sound and music and engineering to, I guess, make our concerts cooler. Drums.